Hi, Nate and Gary. I'm just going to show you quickly. I think it's this part that you guys are had questions about. Experimental versus theoretical proportions. And it's pretty, it can be complicated sounding, much more than it is difficult. Um, you just have to know the difference between theoretical and experiential probability. Theoretical is, you know, in theory, what's the answer going to be? Experimental means basically I've tried it and this is the outcome I have. And the question becomes, does my experiment match my theory? And that's how I know it's true. So for the theory part, we count up, well, how many slots are on in this circle or the spinner? And we see that there are 10 slots. And then we count up how many different size colors are there. There's white, so there's 4 white. So the theoretical proportion of getting it white on land on the white would be 4 out of 10. The theoretical proportion of getting gray would be 4 out of 10 because there's 4 gray slots. And the theoretical proportion of getting black would be 2 out of 10 because there's 10 total spots and only 2 black. So there's a 40% chance of getting it gray because 4 divided by 10 is 0.40, and that makes it 40%. There's a 40% chance of it getting white, landing on white, and there's a 20% chance of landing on black. And that's your theory. That's your theory. Now, they've run some experiments here to figure out whether or not the theory matches the practice, okay? So if I'm looking at A, this is saying, assuming that the spinner is fair, compute the theoretical probability of landing on gray. Well, 4 gray slots out of 10, there's a 40% chance, or 4 out of 10 chance that's going to land on gray. Then it says for Maria's results, compute the experimental probability of landing on gray. Okay, well, it looks like they spun it 1,000 times, and 421 times it landed on gray. Perfect. You know what that tells us? If we do 421 divided by 1,000 on a calculator, you're going to get, I believe, 0.42 or 0.421. So, and that makes it 42%. So there's about a 42% chance that's going to land on gray when you do the experiment. Now the question then states for C, assuming, I'm going to pull this off here, assuming that the spinner is fair, choose a statement below that is true. The larger number of spins, the greater the likelihood the experimental probability will be close to the theoretical probability. Yes, because when you're talking about experiments, the more you do it, the more you'll see a pattern. So if you only flip a coin 10 times and 8 times it's heads, the idea is that if you keep flipping that coin, you'll have closer and closer and closer to being 1 out of 2 chances, either heads or tails. So the more you do something, the more likely it is to come true, to become an accurate picture of what will happen. So they spun the spinner 1,000 times, and so that's a pretty accurate gauge of what this is going to be. If you look at the second one, it says the experimental probability will never be very close to the theoretical probability, no matter the number of spins. Well, that's not true, because we proved it right now when we said the experimental probability was 42% and the theoretical probability was 40%. So that's inaccurate. The smaller number of spins, the greater the likelihood that the experimental probability will be close to the theoretical probability. No, because when you do experiments, the smaller amount of times you do experiments, then you leave opportunities for things to be an anomaly or outside of that, or outside of what's going to happen. The more you do something, the more you're going to see a pattern evolve, and that's what you're seeing in this type of problem. You're seeing a pattern evolve for theory versus experientiality. Okay, so and that will show you here because we have 40% here and 42% here. That's pretty darn close to being accurate. The theory is very close to the experiment. If you only did it, let's say, 2 times, you may not land on any gray. You may land on white and black, and this would be 0, and this would be 40% still. And that wouldn't be accurate. So the more times you experiment with something, the greater the pattern will evolve out of that, and you'll see the accuracy.